Hello, hello, everyone. All right. It is Super STEAM Saturday time. All right. So, Tracy and Eric and helpers, are you ready? Yes? Give me the heads up. Okay. All right. All right. Hello, everyone. Welcome to Super STEAM Saturday. And I just want to mention that we are recording. So if you don't want to show your camera, that's fine. If you do, we would love that because we love to see people. But welcome to Super STEAM Saturday. And this is going to be a really exciting Super STEAM Saturday because we have Dr. Tracy and Eric Schwab, who are chemistry faculty at WCC. They are going to do a really cool session. We wish it was in person, but we understand it's got to be virtual right now. And I'm going to turn it over to Tracy and Eric, and I think we're set to go. Is that right, everyone? All right, so I'm going to mute myself and let them take over, okay?
Okay, great. Hi, everybody. So if you have a piece of paper and pencil handy, we're going to be doing some quiz questions for you throughout the session. So we're going to do one quick quiz session now, and then we're going to do them interspersed, okay? And then we're going to be doing demonstrations. So welcome. We're actually coming to you live from one of our WCC chemistry laboratories. And I actually have Zoe here. She's a current student at WCC, so she's going to be helping us do this today. So we appreciate the fact she's taking some time out of her busy schedule. So the first quiz question, are you guys ready? Let's see. Now don't shout it out, but you can put it in the chat. I have somebody over here that's looking at the chat. We're going to give you a little time. So if you guys know chemistry, what chemistry is, folks, it's the study of looking at how substances behave and how substances behave with each other. Now, substances are made up of something called elements. For those of you that have had a science class, you're probably familiar with the periodic table of elements. So a lot of our quiz questions today come from that. So the first question is, which element, we're going to give you a choice of 4, is the most abundant in the human body? So we're going to give you 4 choices. You can zoom in there. So what do you guys think? So we're going to give you a little time to think about what element do you think is the most abundant in the human body? Okay, so I'm going to take one down now. So if you put gold, that wasn't right. If you put carbon, that wasn't right. And what's the last one that goes down? So did anybody put oxygen? Don't know. But if you did, give yourself a point. Okay, now what we're going to do now, folks, is something regarding fireworks. So if you guys ever watched fireworks and you see certain things are red and blue and purple, well, it's been known for thousands of years that some specific elements burn a very characteristic color in a flame. So we're going to be doing that for you today. I'll go ahead and do the flame for you. Paola, could you? Yep. Okay. So what you're going to see Zoe do, if you guys look at the blue flame here, you guys will notice the first thing we have to do is to clean the flame. So if you guys ever take a chemistry class, can you guys see that there's 2 blue flame colors in there of the flame? The tip of the inner blue flame, which is where Zoe's putting the platinum wire in, she's going to put it in there till it burns clean. Now we're going to go ahead and put it in an element, and let's see what color it makes. It's going to be really fast, this one. Can you guys see it's a little purple? Might be a little bit hard to see over Zoom, but that's potassium ion. So potassium is very known to burn a very purple color. Now, in between samples, we have to clean the wires, so we don't want any contamination of the purple to come back. So she's going to dip it in an acid. We're going to clean it. So you can see as she lets it sit in there, the flame the color goes down and down and down. Just the wire glows. You go ahead and put it in the next one. Now this is sodium. It's going to burn a yellow. So you're going to see that yellow color. So there's the yellow. So sodium has a very characteristic color in a flame. Great. We're going to clean it again. We're going to do 2 more for you here. Just going to clean the flame first, and then we're going to do copper. And probably the most coolest one is strontium, which we're going to do here. These are all elements. So this next one is copper. It might be a little hard to see, but it does do a blue. I don't know. You can see a little bit. It was just really quick at the beginning. Kind of probably looks a little bit more greenish, but it's a little bit more blue if you're in person. Now the last one, if you guys ever watched fireworks and saw red fireworks, this is the element that they use. It's called strontium. So this one's probably, even our students here at WCC, they love this one because it's pretty red. So you'll see that pretty red. And so if you guys ever come and take chemistry courses at WCC, a lot of times we can identify what metal ions are present based on what color they produce in the flame. Okay? Go ahead, so do you want to do this after the next one? Okay, go ahead. It's going to go over to another demonstration here.
Hi there. I'm the other Dr. Schwab. One of the most important things when working in the chemistry lab is to wear goggles. I'm going to show you a couple of things of why we take safety so important in the chemistry lab. If I got goggles on first, this is a penny. Probably all seen those. In this beaker, I have nitric acid, concentrated nitric acid. Again, this is why we emphasize safety in the lab. Watch it for a couple seconds. You can see it turning green. And a nice brown smoke comes. It's actually dissolving the penny. So if I leave that in there long enough, we will not have a penny anymore. Okay, so that's one strong acid. Now in this beaker I have sugar, normal table sugar. And this bottle is sulfuric acid. Okay, I'm going to get that going. You can see the penny is still dissolving. So if you look at this chart right here, what's going to happen with the sugar is sugar is what we call a carbohydrate. It's basically a carbon and water molecules attached to it. This breaks down to that. Well, sulfuric acid is such a strong acid that it does what we call dehydrating sugar. So it takes all the water out of sugar. In a minute or two, when this gets darker, we'll see something better happen. I'll call you back when it happens.
Okay, so we're going to come back here. Okay, so we just have some quiz questions while we're waiting for that reaction to happen. So you guys ready for the second one? Let's see if you guys get a point on this one. What is the most common element in the universe? So we're going to give you 4 choices here. Okay, so we're going to give you guys a second to think about that. Again, these are just 4 elements. Okay, let's take one away. Okay, we're going to take another one away. Okay, and last one. Did anybody pick hydrogen? If you did, give yourself a point. Okay, we're going to do one more of these. Okay, so some elements have been known to people for thousands of years, like gold, for example, before they even knew it was an element. So here's a kind of a trickier one. What was the first element that was discovered by a scientist using chemistry? Okay, he had to do experiments to figure this one out. So this might be a little bit more tricky. So we'll see what you guys get with this one. So it's aluminum, helium, phosphorus, or calcium. So let's see. So this is the first element that was discovered by scientists using experiments. So we're going to go ahead and put one down. Going to put another one down. Okay. And one more. Anybody pick phosphorus? It was actually phosphorus for that one. Okay, are we going to go back to the sugar now?
Not yet.
Okay. We're going to go on then here for this one. Okay. In ancient Egypt, what element was more valuable than gold? Ooh. All right. Okay, so in ancient Egypt, what element was more valuable than gold? Okay, so I'm going to take one away. What are you guys thinking? Okay, put another one down. Put another one down. Anybody pick silver? Silver was actually more valuable than gold. Did you need more time? Eric, did you need more time?
Almost there.
Okay. So while we're waiting for that, we're going to go ahead and do another technique here. We're going to put our goggles on for this one. Oops. I'll just pull it out. Okay. Now, since atoms, which make up elements, which make up substances, they're too tiny for us to see. There's no microscope that's big enough to let us see what this looks like. So when we do chemical reactions in the lab, there has to be some way for the chemical reaction to let us know that a chemical reaction is taking place. These are called indicators. So in chemistry at WCC, we kind of show students the big four indicators. We're going to show you a couple of that today. So hopefully you'll be able to see this. So just let us know. So you have a test tube here that contains a substance, an acid, and we're going to drop some copper wire in there. So you kind of saw something that looks similar to this. So if you can you zoom in there and let me just put a white background in the back if you can see that. You can see the solution got very green. Now there's an orange gas that's creeping up.
Okay, come back over here. Now, if you look closely at the sugar, something's growing. We don't time these things, so. There we go. So the sulfuric acid is dehydrating the sugar, taking all the water out of the sugar. And what you're getting, that column that's coming up, is basically carbon with a little sugar. And it actually smells a little like caramel. I wouldn't breathe it or eat it, but. So this is what chemists, why we have to be so careful in labs, because we work with stuff that can dissolve metals and dehydrate sugar, skin, stuff like that, okay? All right, thank you.
Okay, now we're going to go back to this one. So as you guys can see, this is actually one of the experiments that we do in lab. You want to hold that, Sylvia? Is it's going to produce that orange gas. And if you actually can also see there's a little bubbling. So gas formation is one of the major indicators that allows us to tell that a chemical reaction is taking place. So we're going to go ahead and put that away. Now do you want to go to there and get it set up?
No, I got it.
Okay, so the second one here is we're going to look at something a little bit different here. This is ammonium chloride. Now you guys saw a couple examples where gases were different colors. For example, orange. What happens if a gas, what happens if the gas is clear? How do students see that if the gas is clear? Well, here's one. So we're going to take, it's ammonium chloride, it's a solid. We're going to dump in, you can do a couple big squirts there, of this. Now it's going to produce a gas, but you're not going to see it. So we're going to mix it up. Put in a little bit more. Yeah, that'll have you with it. And just cover it with your thumb. So folks, this is going to produce a gas that you won't be able to see. Now we're going to be using something called litmus paper. So it's little pieces of paper that have a dye on it that change different colors if you have an acid or a base present. So what's happening is this chemical reaction is taking place. It's actually producing ammonia, which is, you can see she has her thumb over it, so it's not going to let us escape. But how do we know it's there? So if you take your thumb off, you put it in there, can you guys see how the litmus paper turned blue? So you can see that. So it's kind of another indicator. So some gases are clear, but we can tell based on the color that litmus paper, that it turns litmus paper. Now the last one is another very vigorous reaction. So in the test tube are some pieces of magnesium metal, but we're gonna add some HCl. And what happens, folks, is there's a chemical reaction taking place, and you guys can see the vigorous bubbling there. Now, given enough time, those metal pieces will actually dissolve. And so in our chemistry labs, the students watch this, and then they have to write the appropriate chemical reaction down. Okay, so again, atoms that make up elements are too small for us to see. So there's got to be a way for us to be able to see when a chemical reaction takes place. Are we back to you yet? Okay, we're going to go to another question. Okay. Give you 4. So while we're just getting some stuff set up. So for question 5, some of you may know this, we'll see. What element is crucial for helping carry oxygen around in your bloodstream? So this is a specific element that your body needs to carry around oxygen. If any of you know a family member who's been told by their doctor that they're anemic, there's usually something that they have you take as a supplement. So we're going to put the 4 possible choices up. So we have potassium, iron, titanium, and chlorine. Okay, so what element do you think is crucial in carrying oxygen around in your bloodstream? So we're going to put down the first one, potassium. Okay, we're going to put down the second one. We've got 2 choices here. Okay, last one down. It's iron. So if you ever get tested by your physician and you're what they call anemic, they might prescribe you to take some iron supplements. Does anybody know what element, one of the major elements that's present in bananas? That's actually potassium. Yeah. Okay, back to you.
Yeah.
Okay, we'll get on.
So can anybody guess what the weight of the air column above your head weighs, extending up to the atmosphere? I looked it up. It's about 10,000 kilograms. Now, does that feel like there's 10,000 kilograms on you? Probably not, because we're used to it. We can do this nice little experiment. I've got a little bit of water in these pop cans. And what I've done is I've heated it up. And heating it up makes the molecules move a lot faster. And so as they move faster, they push the air that was in the pop can out, and they're pressing against the side of the aluminum. Now what I'm going to do is I'm going to pick one of these up, and I'm going to invert it into this cold water bath. And that's going to immediately slow all the hot water molecules down. So they're going to stop, almost stop. Since they're hitting the sides of the can, they've kind of built up some pressure in there. But when they cool down and condense, the pressure's gone. The only pressure exerting itself on the can is going to be the atmospheric pressure. So let's see what that'll do to the can. So without burning myself. So that can was crushed just by the pressure of the atmosphere. Let's do it again. That was fun. So it took a couple of seconds for the water to cool down enough. And so think about that when you feel the air pressing against you.
Amy, is there any questions in the chat at all?
So what I'm doing over here in the speaker is I'm going to coat what's going to look like a penny with silver and a penny with gold. So I've got this reaction going. We'll come back in a couple of minutes to show you what's going to happen with it. Ooh, that's really
Okay, so we're going to go back to some quiz questions here. Okay, that was question 5. Let's put that away. Okay, so number 6. Give you a couple.
Hey, Tracy.
Yes.
We have a question in the chat. Why don't I implode?
because the pressure on the outside of your body is more or less equivalent to the outside pressure.
Yep. But if I'm sure you guys have heard, if you go to certain pressure elevations, like go down very far to the bottom of the sea, there's going to be so much pressure down there that will not sustain a human being to live. But yeah, I'm sure we can experience slight pressure changes, but not enough to harm us typically. That's a good question. Okay, so as you heard, we're doing an experiment with nickel. We're going to be coming up and doing nickel. So out of curiosity, a nickel, 5 cents, what is it primarily made up of? What element? You would think that it's, oh, I'm not going to answer. I was almost going to give you the answer. So a nickel, 5 cents, is primarily made up of what element? Okay. Oh, there goes one. Now we have 3 choices left. Okay, put down another one. Did you guys pick nickel because it was nickel? That's wrong. Okay, it's actually copper. And so we're going to be doing that experiment here in a moment. So copper, I don't know if anybody put that down. Okay, give yourself a point. Now, have you guys ever watched Raiders of the Lost Ark? That might be kind of an old movie. But any movie where they discover something, an artifact made thousands and thousands of years ago, and which can be very valuable. So when somebody discovers something, there has to be a way to test to see how old it is. And there's a specific element, a specific isotope that we use for that. So what element is used to determine how old something is? Okay, so here's your choices. This element, it's the radioactive form of this element that's used for, called radio dating, determining how old something is. So again, if somebody finds something and they want to see how old it is, there's a specific element that they're looking for. So it's not sulfur, okay? And it's not tin, so we're going to put that away. Okay, go ahead and put the last one down. Did anybody pick carbon? Carbon is the answer. So what happens, folks, as you're living, you have a specific carbon 12 in your body, and as you're getting older, that carbon's being replaced by the radioactive form of carbon. And that's how folks can tell how old something is. Are you ready to go there?
Yeah.
Okay.
So the next thing I'm going to start going is, we've got in this test tube potassium chlorate. And what potassium chlorate is, it's a potassium atom with a chlorine atom and 3 oxygens. When we heat it up, it decomposes into potassium chloride, which is a lot like table salt and oxygen. Kind of boring. But let's say we take that oxygen and put a gummy bear in there. What's going to happen? It's going to take a couple of minutes for that to melt, and then we'll put a gummy bear in there, and we'll see what happens. It's quite dramatic.
Do you want it to be the toothpaste or that's?
Oh yeah. So one other thing we're going to do, a lot of chemical reactions are pretty slow, especially the ones that we use for industrial purposes. And so chemists do something called adding a catalyst. And a catalyst is just a compound or a substance that increases the rate of a chemical reaction, but isn't changed in itself. So a lot of companies use platinum dust. It's a very good platinum for very good catalyst for a lot of organic reactions, but it's really easy to recover. And you can keep reusing it and reusing it and reusing it, which is good because platinum is very expensive. Well, in this graduated cylinder here, it's green, but what I have in here is mostly hydrogen peroxide, and we use that for disinfecting wounds and stuff like that. A little bit of dish soap just for drama, and some food coloring so you can see what it looks like. Now, hydrogen peroxide normally degrades on its own into water and oxygen, but it takes quite a while. We can add a catalyst, though, and it makes it go a little bit faster. That's what the soap bubbles do. All that oxygen is making the bubbles with the soap. And this is nice because it's easy to clean up because it's just all soap. Okay? You could probably do this at home. The trouble is, it's hard to get iodine in the in Myers or Kroger's. Okay. Oh, we're almost ready for the gummy bear. Where are the gummy bears?
Okay. Okay, let's go back to a trivia question while he's locating his stuff. We'll do one more here. Okay. So if you guys drink pop, soda pop, you shouldn't drink too much, right? Because the sugar will hurt your teeth. But when you crack a can open or a bottle, you hear that, right? There's a gas escaping. Okay? So what gas is present in Pepsi, Coke, root beer, whatever you guys like to drink? Okay? So here's 4 things that you could have. You could have oxygen gas, water, helium, or carbon dioxide. What gas do you think is present in carbonated beverages? Okay, so not helium. Okay, not oxygen, so you have these 2. Did anybody pick carbon dioxide? That is the answer. And if you guys ever leave a pop open enough, do you guys realize, and you drink it, you go, ooh, it tastes flat. That's because all the carbon dioxide has escaped. I had a friend of mine many years ago who used to only drink flat pops. She'd take a knife and stir it. That will actually get the carbon dioxide out quicker. Okay, now back to that.
All right, so our potassium perchlorate is melted. It's driven off a lot of the oxygen. And I have the sacrificial green gummy bear. So let's see what happens. So the purple, that flame comes from the potassium perchlorate. Poor gummy bear.
Poor gummy bear. It makes a mess. They
I'm
want
sorry,
to do
but that's
another
cool.
one. Can you throw another gummy bear in there?
Use a bubble
Okay.
potassium perchlorate.
Okay.
You should have told me that. We had another one ready.
Okay. Was that the last one you had?
Oh, we gotta show that.
Oh, yeah. Okay. Or you want to show that, or you want to do the next quiz question?
Tracy, we have a question again. I had someone ask, so what happened again to the gummy bear?
Oh, so the gummy bear is basically mostly sugar. Okay, and for a fire to occur, you need a fuel source, the gummy bear, and you need an oxidizer, the oxygen that was given off by the decomposition of potassium chlorate. The oxygen was very hot because it came from a molten solution. So you get the heat, the oxygen, and the gummy bear, and you get a fire. And we got the purple color because there was potassium in the solution when it melted.
So the gummy bear is consumed.
And the gummy bear is consumed because this is the fuel source.
Okay, so we have one more quiz question for you. So this is number 10. Actually, no, number 9. Oh, where did I put it? I'll find 9. I don't know where I put it. Okay, so this is number 10. What element do you, and this should be easy, what element do you think was named after United States, a state in the United States? So one of the 50 states had an element named after them. Probably pretty easy on this one. Can you guys catch it there? Okay, so we're going to put one down. We're going to put another one down. Okay. Did any of you guys see California, named after California? Super cool. And one more, which I completely, I think, got all the questions mixed up, but are you ready for your next one there? Or you want another quiz question? What do you say?
One more.
Okay, that's all last one we have. Okay, now this is always a question that I find fascinating. What is the most expensive element in the world? Wait till you hear the price of this. What is the most expensive element? So there's 4 choices here. Okay. We're going to put one down. How many put gold? It's not that one either. It's francium. If you have 1 gram of this, it's going to cost you $1 billion with a B dollars to make it. Francium. And the reason is, folks, this does not occur naturally on the planet, in the universe. It actually has to be made in the lab. And to date, only a few atoms have ever been made. So if you ever become a billionaire, maybe you might want to make a gram of francium. Who knows? We'll see. Are you ready?
Yep.
Okay. Get out of here.
Okay, so this is kind of a way to maybe make fake silver pennies and gold pennies. So what I had in here was a solution of zinc chloride with a little bit of powdered zinc. And I just let the pennies sitting there for a while it was boiling, and it looks like the penny's gold, or silver rather. Now, if I put the penny back on the heat, we'll just let it sit there for a minute or so. It's going to be hard to see on the camera, but I'll hold it up when it turns. There it goes. Flip it over like you do a good burger. Oh, it's turning now. Okay, it's going to take a little bit longer than I wanted, but this is what it looks like when you're done. It looks like we have a silver penny and a gold penny. Now, obviously, they aren't really silver and gold. The silver one is just a coating of zinc. So, like your kitchen faucets and your bathroom faucets, they coat them with, plate them with chromium to make them more durable. This is the same thing. We're coating it with zinc. Now, the other penny looks like gold. If there's anybody out there that plays a trumpet or a trombone or a tuba, you know they're made out of brass. Well, that's what this is. Zinc plus copper. We plated it with zinc. The copper was on the penny, makes brass. So this is just a quick way of counterfeiting coins. But you didn't hear that here. That one looks really gold now. Okay.
Okay. And the last demo we have for you, because it kind of went a little bit quicker than we thought, was you heard us mention a couple times that we were doing some experiments and demos with you today that involved acids and bases. Now, a long time ago, people used to eat or drink things to determine if it was an acid or a base. Acids were very sour, biting taste, and bases were soapy. So a lot of times they would eat or put on their skin. Now we know now that that's probably not a good thing to do, right? You shouldn't be going around a chemistry lab eating, drinking, or pouring things on your hand. So we saw this before, but we use a couple things in the lab to determine whether something's an acid or a base. And I hope when you guys go on to take chemistry, as you all should in high school, you're going to learn that acids and bases are very important because they react a specific way. So for example, carbonated pop, Pepsi, Coke, that's actually a very weak acid. If any of you guys had a stomach upset and your mom or dad or somebody gives you Tums or something to make it settle down, that is a base which neutralizes the acid in your stomach. So what you're gonna see here is some litmus paper. And you can see, now we call this red litmus paper. I have students that say it's pink, but we call it red. And this is blue litmus paper. So a lot of times what we'll do in the lab, now this is not as dramatic as some other things that you saw, is I'm just gonna take some acid and dip it over on a stirring rod. But I'm gonna come back here. And I am going to touch these two things here. And hopefully, if you guys can see it well enough, I'm trying to put some white paper maybe to make it contrast a little bit. But if you guys can see, the acid turned the blue litmus paper, I don't know how well that's projecting, the blue litmus paper kind of turned it pink. So in the lab, we're not going to taste it or drink it or put it on our hands. We're actually going to test to see if it is an acid or a base. Now, acids and bases are very important in your body. For example, your bloodstream is about 7.4 pH. It's on a scale of 14. So a lot of times if you're getting sick and they don't know what's wrong, they'll take a blood sample and possibly a urine sample as well. And one of the tests that they do is a pH to kind of diagnose to see what you have. So that's all of the demos that we have today.
One more thing. Remember that penny that we started dissolving earlier? It's gone. It's turned into a nice copper nitrate solution.
So at this point, we wanted to see, I know we have a few minutes before the session, but if anybody had any questions.
Tracy, what is litmus paper made of?
Oh, it's just a composite of paper with a specific dye. It's a specific chemical, a dye, that changes color in the presence of an acid or a base. So it's a big, long, big molecule. But we do know that there are certain chemicals that change color, whether it's acidic, basic, or neutral, but it's a big conglomeration of a big molecule.
We have another question. Can you recover all the chemicals you use, or do they all go down the drain?
Oh, that's a really good question. So at WCC, we try to recover as much as we can. Now, what we do is we have all the students, so you probably can't see, but behind us we have waste jars where when students do experiments, we have specific containers that the students put it in. A company then comes on to site to take the chemicals away, and those specific companies can actually do other chemical reactions to bring back certain metals. So they can recover or recycle certain things. Now, some things that we do in the lab are really harmless. So sometimes, if you ever take a chemistry lab, we can dump some things down the drain, such as very low concentrated, very weak acids, bases, sugars, depending on what we do. Now, other substances, again, that we make that cannot be recycled, then those get disposed of properly. But at WCC, we really try to be careful and be mindful of what chemical reactions we're doing here on campus, so that we don't generate a ton of waste. That's a really good question. Was there any other questions anybody had today? And I hope next time, fingers crossed, that you guys will actually be able to come to campus to do this, because we actually have a couple stations set up. We have some mysteries for you guys to solve, but we didn't think it would translate all that well over Zoom this time. But I hope you guys found some of the things that we did today interesting.
Karen is saying, yes, I want to.
I do too. I was really hoping that we could be on campus this semester, but hopefully next time.
You're getting lots of compliments. Corolla says that would be nice. It was interesting. Ajane says, yes, I loved it.
And you're all going to be chemistry majors now, right? Right? You're all going to be chemistry. I'll be checking up. I expect
Lauren says, this was really amazing. Thank you so much. What made the copper disintegrate?
Just the strength of the acids. Acids are known, they're very good solvents. They dissolve a lot of things, and metals are one of them. So that's why I just got a drop on my hand and it's still stinging.
Talk about letting your money poof off into.
That's right. That is really right. Any other questions from anybody today?
Ajane says, I want to study chemicals. So you have people interested.
Yeah. Come to WCC. We do a great job with our first 2-year chemistry students. Zoe here has actually gone through most of the chemistry classes here, which is why I wrote her down at this time. So very lucky to have Zoe this morning.
We have another question. Do you two ever play chemistry at home?
Only when I cook.
Yeah, cooking.
Like practical chemistry.
You don't have any explosions though while you cook, do you?
No,
Okay.
and to be clear, I still have students that come into labs today that go, can we explode something today? And my answer is always, no, we do not. But cooking. So folks, you can actually get books on cooking, what happens chemically when you cook things. And when you guys get to be 21 years of age and can drink beer, alcohol, brewing, making alcohols, also it's chemistry. So there's a lot of things that involve chemistry, not just torturing students in the chemistry lab.
Karen says she wants to study chemicals too.
Oh,
And
nice.
Ajane says she loves to cook.
Oh, good. Chemistry, a lot of chemistry in there.
I guess here's another comment. Harold McGee has written books on the chemistry of cooking. I think I have the right name. That's right.
And I know there's also Alton Brown that does a lot on the Food Network, where he actually talks about the chemistry behind the things that happen in cooking. So yeah, there's quite a few books on that, but absolutely.
A lot of people saying I love chemistry here.
So do I. Yeah.
Oh yeah, yes, just Googled it. Harold McGee is the right name. Okay. Okay, very good.
Good.
Any other questions for the Schwabs or for Zoe? Any other questions?
Well, it was great seeing you all today. And like I said, hopefully next time we will be together in person, which will be much better.
Oh, I have a question. Zoe, what are you going to do next?
Oh, well, like, what am I majoring in? Is that the question?
Is that the question?
Okay. So I am actually majoring in biology. I'm not majoring in chemistry, much to the Schwab's disappointment. But my goal is to become a doctor, so I will have to work with chemicals.
And Zoe is a STEM scholar, and we love having her in the STEM scholars. And Zoe is right now applying to go to the University of Michigan. So we're hopeful for Zoe. And thank you, everyone. We are so glad you joined us. And thank you to Dr. Tracy and Eric Schwab and to Zoe for making this a really fun session. And all the rest of you have a wonderful day, and we'll see you for our next Super STEAM Saturday. And we always put recordings of our Super STEAM Saturdays up on our site, so you can watch them later too. So everyone take good care.
Okay, bye everybody.
Bye.